Hey guys, Dr. Brown with Kubo Math coming to you from Tarlac City, Philippines, and we're still on the series of where did they get that formula. So tonight we're looking at differentiation of cosecant x. It's said that that equals minus cosecant x cotangent x. Where'd they get that? So that's what we're going to talk about. Okay, we're going to use the limit formula where the derivative of f of x, we're going to set that equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So let's get after it. Okay, now I've written the limit down so I don't take up your valuable time, just writing that over and over. So, all right, so if we utilize that formulation, we would have that the limit as h approaches 0 of cosecant x plus h minus cosecant x all over h. Now we know that cosecant is 1 over sine. So let's go ahead and change it to that. So we would have 1 over sine x plus h minus minus 1 over sine x, and I'm going to flip my h up into that denominator if you don't mind. So I'll put my h here and here. Now in order for us to put these two together, or subtract the two, I need to get a common denominator. So let me multiply this side here by sine x over sine x, and this side by sine x plus h over sine x plus h. Okay, multiplied both sides by 1. So I end up with sine x minus sine x plus h all over sine x plus h h. Okay, now we can utilize this sine x plus h formula that equals sine x cosine h plus cosine x sine h. Okay, so now you'll notice we have a negative here. So since both of these are positive, and we're subtracting them, both of those will end up negative here. So we would have the limit as h approaches 0 of sine x minus sine x cosine h, sine x cosine h minus cosine x sine h. All, well actually I'm going to separate those two out right here, over sine x sine, I'm going to leave the x plus h here, h, and this one's over sine x, all the same, sine x plus h over h, or h. Okay, so we're taking that limit. Now you can see in this case we've got a sine x we could factor out. So let's head up here with this. We still have the limit as h approaches 0, but I'm going to factor out the sine x. So I have sine x times 1 minus cosine h over sine x times sine x plus h minus, so we get everything there with sine x times 1 minus cosine h over all of this, minus, I'm going to, well, we'll just keep rolling here, cosine x sine h, we'll just really just writing this side down, sine x plus h. Okay, let's go through with some of our limits here. If we take h cosine h is h approaches 0, this approaches 1. So 1 minus 1 gives me 0. 0 times this is 0, so this entire thing becomes 0. So now we're still just working with this limit. Well, sine h over h, that limit as h approaches 0 is 1. We studied that in a previous video. Just put your calculator on radians and take sine of 1 times 10 to the minus 6. We're just assuming that's approaching 0, and that divided by 1 times 10 to the minus 6. When you put in that number times 1 times 10 to the minus 6, it becomes 1 times 10 to the minus 6, and that divided by itself is in fact 1. That's not so obvious to me, so it may be to you, I don't know. Okay, all right, so that is 1. So now we have minus cosine x times that 1 divided by sine x, and then sine of x plus is h approaches 0, it's just sine x. Of course, this h was divided out into that. So now I've ended up with this. So if I change that to 1 over sine x, that's a negative. So negative 1 over sine x times cosine x over sine x. So that's my sine squared x here. Well, what is 1 over sine x? It's cosecant. We have a negative, so it's negative cosecant x. And you know sine over cosine is tangent, so cosine over sine is cotangent. Oh. All right, so the derivative of cosecant x, they said was minus cosecant x cotangent x, and we confirmed that that is in fact the answer. So the derivative of cosecant x is minus cosecant x cotangent x. Why are we doing this? Hey, together we're trying to build a better tomorrow and do that through math. Okay? Study, study, study. I say it every video. You can only get better by studying, trying real hard. Work, work, work. Learn, grow your mind. Okay? All right, that's all for now, and I guess we'll talk to you next time. Hey, keep studying. We'll talk to you soon. Thanks. Bye.